Hi students, this is Mr. Yao. In this lesson, we are going to learn how to solve quadratic inequalities. So first, let's review how to solve inequalities and how to express the answers as interval notation. First one, subtract 2 over, we're going to get x is greater than or equal to 3. If you want to graph that, it's a solid dot on 3 because there's an equal sign and it's pointing to the right. And that in interval notation is 3 with square brackets since that's indicating equal sign or the dot to infinity. B, add 4 on both sides. 3x is less than 9. Divide both sides by a 3. X is less than 3. So in this case, if you want to graph it, no equal sign, so it's open circle on 3. And the arrow is pointing to the left, just like the inequality sign. So means start from negative infinity all the way to 3. But since it's open circle with no equal sign, we're going to use parentheses. Next, add 12 on both sides. Negative 4x is less than or equal to 20. Then we need to divide both sides by a negative 4. And whenever we multiply or divide by a negative number, we got to flip the sign. So x is greater than or equal to negative 5. So number line equal. So it is a solid dot on that negative 5 and it's pointing to the right. So square bracket negative 5 to infinity. Next one, subtract 7 over. So we got negative 2 is greater than. That's negative 2 minus 7 is a negative 9. Negative 2x is greater than negative 9. Divide both sides by a negative 2, so x is less than 9 over 2. So negative infinity to 9 halves. Both sides are going to be parentheses. There you go. Solving quadratic inequalities is almost the same as solving quadratic equations. The best method are solving by factoring and quadratic formula. So in this lesson, any question that I can factor, even though I can also use quadratic formula to solve them, I'm going to deal with them using the factoring to kind of remind you how to factor. Here's the example. Step 1. Put inequality in standard form, which is ax squared plus bx plus c on the left side and 0 on the right side, just like when you solve the equation. So that means we need to move the negative x to the left side. So it's x squared plus x minus 12. That is less than or equal to 0. Next, we're going to need to solve the equation, treat it as an equation, and solve it by factoring or quadratic formula. We can actually factor. So it's going to be x plus 4 times x minus 3. That is less than or equal to 0. Next, we're going to draw a number line to actually graph it visually first before you actually write down the interval notation. Draw a number line and label the zeros on the number line. So this is going to give me a negative 4, and this one is going to give me a 3. So it's a negative 4 and a 3. The reason I'm putting solid dot already is because I see the question has less than or equal to, so there are equal signs. That's why I'm just already drawing down as the dot. Next, these 2 points separate the graph into 3 sections, and we need to decide which one of these sections or ones of these sections we are going to keep. So here's what we're going to do to decide which part we're going to keep. We're going to pick a random number in each section on the number line and plug into the quadratic to check if the answer is positive or negative, and then decide which section satisfies the inequality and put a check mark on that section. This is a pretty general method. We'll actually learn a more faster method later in the lesson, specifically for quadratic. But this general method, you are still going to use it in next year, even for some more complicated equations that you need to solve. So let's have a look. Number less than negative 4, let's say we're going to pick negative 5. In between negative 4 and 3, between negative and positive number, let's say we're going to pick 0. And then above 3, let's say we're going to pick 4. As you can see, my dot or open circle for the zeros, I'm already going to draw them. But for these numbers, I'm just going to put in a little tick to indicate these are the numbers I'm picking to check. And here's what it means by checking. You're going to plug negative 5 into the original equation. So you can either plug it in here or plug in here, whichever is easier for you to check. Let's say I'm going to plug into this bottom one. I'm going to get negative 5 plus 4 times negative 5 minus 3. That is a negative 1 times a negative 8, which is a positive 8, less than or equal to 0. That does not work, so that means this section does not work. Next, for 0, 0 plus 4 times 0 minus 3, that is a 4 times negative 3, which is a negative 12, is less than or equal to 0, and that actually works. So this is a check mark. Next, plug in 4, we got 4 plus 4 times 4 minus 3, so it's an 8 times 1, which is an 8. less than or equal to 0 does not work. So as you can see, after checking, only one section got the check mark. And then we're going to write all the checked sections using interval notation. And that's why, as soon as I draw the number line, I already indicate if I'm going to write them as solid dot or open circle. So when I write the interval notation, it's very fast, very easy. So the middle part is checked. So I'm going to start from -4, stop at 3, and they are both solid dot, so square bracket. And that is my final answer. And that's how we solve quadratic inequality. Let's look at another example, example 1. Go through the same process. Everything's already on the left side with a 0 on the right side, so we can move on to the next step. Factoring or quadratic formula. We can factor again on this one. X minus 1 times x minus 2 is greater than or equal to 0. Step 3, put a number line and put these answers on there. There's one extra thing you can even separate more. You can put the zeros on the top. And this one also has an equal sign, so it's going to be a dot on 1, and it's also going to be a dot on 2. So the zeros I'm going to put on the top. The points I'm going to use to check, I'll put them on the bottom. So there you go. Let's start picking points. We can pick 0. And in between 1 and 2, you can't pick 1 or 2 because they're just the separating points. Let's say you are going to pick 3/2, and you can also pick 3 on the right side. For 0, I'm plugging in either here or the original. Either way works. So picking 0 actually is easier to plug into the original because the x squared and the 3x are just going to be 0. So the 2 is greater than or equal to 0. That works. So this section got a check mark. Next, 3/2. So 3/2 minus 1 times 3/2 minus 2. That is 1/2 times a -1/2. So it's -1/4. Greater than or equal to 0. Does not work. Middle section got a check, got a cross. And 3 minus 1 times 3 minus 2. We got a 2 times 1, which is a 2. Greater than or equal to 0. That works. So now, finally, we just write the final answer. So the left side and the right side works. So the left side starts from -infinity, stops at 1 because it's a solid dot, which means it's going to be a square bracket. The right side starts at 2, square bracket, going all the way to the right, to infinity, with a union symbol between. And that is my final answer for example 1. Moving on, example 2. Same process, but this one you can still factor. It's going to be x plus 3 times x plus 3, and it's greater than 0. Let's put a number line. There's only one answer because both of them are the same. The answer is going to be a -3. No equal sign, so it's going to be an open circle. And next, well, there's only 1 point. That means we're only going to separate this number line into 2 sections. Well, then you just check the 2 sections. So however many sections you have, you just check that many. So left side we can pick, let's say a -4. And the right side we can pick a 0. 0 is going to be easy. That is going to be 9 is greater than 0. So left side, -4. So -4 plus 3 times another -4 plus 3. That's a -1 times a -1, which is a +1 greater than 0. That works. So the right side not greater than 0, that also works. Left side also works. So you might just be like, wait, both section works. So it's going to be everything. Not quite. There's an open circle in the middle for the -3. So that's going to be -infinity to -3, parentheses, union, -3 to infinity. So that's where you got to be a bit careful. Then, of course, I can choose to change the question a bit. Let's say I'm going to change the question to be less than 0. Well, then suddenly, when you check, you have the open circle, but the left side doesn't work, the right side doesn't work. Well, that will give you a no solution. And for interval notation to indicate no solution is going to be this symbol. It's actually an empty set. Let's say I change the question to be greater than or equal to 0. And then you have this 3 is being a solid point, and the left side works, the right side works. And you also need to include that 3. Well, sorry, not 3, it's a -3. That would actually mean everything works, and that's all real number. In interval notation would be -infinity to +infinity. Now let's say, well, there's only one sign. Let's say the question is less than or equal to 0. Well, I have a solid dot on -3, but left side does not work, right side does not work, but the -3 works. That would mean the answer is just x equals a -3. If you want to use interval notation or set notation to indicate the answer, since it's only one answer, we're going to use curly braces to just include -3 in it. So these are the 3 extra special cases. That's example 2. Moving on. Example 3. Well, this one, let's see. You can't factor. That means we're going to use the quadratic formula. Before you use the quadratic formula, I would always suggest check the discriminant as as a first step. So there we go. -2 squared, that's my b squared minus 4ac. A is 1, c is 12. So it's actually a 4 minus 48, which is a -44. Well, that means there's no zeros. So let's say this is your number line. Well, if there's no zeros, then you can't put any points down. That means you only have one section. So you can pick any point to check. Let's say 0. The left side is going to be a 12 less than 0. Does not work. So that means when you check the one section that's on there, it doesn't work, which means the answer is no solution. That's example 3. Moving on, example 4. First, you got to subtract everything over. 6x squared minus 11x minus 10 greater than 0. Check the discriminant. -11 squared minus 4 times 6 times -10. That's 121. And that is 4 times 6, 24 times 10, -10. So it's a plus 240. The whole thing is a 361. Oh, that actually means this question is factorable. So, but you can use quadratic formula to solve. X equals -b is 11 plus minus square root of 361 all over 2a 2 times 6. This is actually 11 plus or minus 19 all over 12. So the two answers, if it's plus 19, it's a 30 on the top over 12, which is a 5/2. If it's minus 19, it's a -8 over 12, so it's going to be a -2/3. Let's put them down. No equal sign on the inequality symbol, so open circles at -2/3. And then we actually put them on the top. And open circle at 5/2. The points we can use to check, 0 for sure in the middle. And that will leave us a -10 greater than 0. Not work. And then on the left side, we can use -1. So we put it in. That's going to be 6 times -1 squared minus 11 times -1 minus 10. So that's 6 plus 11, which is 17 minus 10. 7 is greater than 0. That totally works. On the right side, greater than 5/2, we can actually use a 3. So 6 times 3 squared minus 10, minus 11 times 3, then minus 10. So 3 squared is 9, 6 times 9 is 54, minus 33, minus 10. So it's 11, greater than 0. That also works. So final answer, -infinity to -2/3, parentheses, because they're open circles, union 5/2 to infinity. That's example 4. Moving on, example 5. Move everything to the left. -x squared plus 4x plus 5 is less than or equal to 0. You can choose to, well, let's factor it out. Negative sign goes out and then becomes x squared minus 4x minus 4. So you can actually factor x minus 5 times x plus 1 is less than or equal to 0. The two numbers we have, -1 and a +5. The points we can use to check, a 0, a -2, and a 6. So 0 is easy. 5 is less than or equal to 0. Does not work. -2, well, that's a negative times -2 minus 5 times -2 plus 1. That's a -7 right there, and that's a -1 right there. So it's a +7, but still a negative sign in the front. -7 is less than or equal to 0. That works. 6, -6 minus 5, 6 plus 1. That's a 1 times 7, which is 7. So -7 is less than or equal to 0. That also works. Final answer, -infinity to -1 square bracket union 5 to infinity. That's example 5. I'm going to leave example 6 to you, and then you can come back to check. I'm just going to do it quietly. -x squared So there you go. That's example 6. Moving on. So these are the general method. Now let's specifically talk about the connection between the quadratic inequality and graphs. A quadratic inequality is actually comparing the quadratic function f of x equals ax squared plus bx plus c with a 0. And when we say that, we are saying we're comparing the function itself with y equals 0, or in other words, with the x-axis. For example, if ax squared plus bx plus c is less than 0, you're going to actually look for any section less than 0 means y is less than 0, which means below the x-axis. So that's what we're looking for. Now let's look at some examples to kind of make the process a bit faster. There you go, example 7. You can actually factor that one. 2x, 3x, greater than 0. So that's going to be a plus 1 here and a plus 2 there. Okay, so the two numbers we got is negative 2/3 and negative 1/2. Open circle on both. Okay, be careful. Make sure you understand that negative 2/3 is less than negative 1/2. 2/3 is actually bigger than 1/2, but since they're negative, so negative 2/3 is actually on the left, negative 1/2 is on the right. So in order to understand how this works, we need to know how to decide if the graph is opening up or opening down. That actually depends on the a value in the front. A equals 6, which is greater than 0. That means our graph is going to open up. So our graph is going to open up, but also go through these 2 points. So our graph has to look something like that. It's not a precise graph, it's just to draw the trend. The question is saying greater than 0, so we need anything that is above this x-axis. So you can see this portion is above and that portion is above. Then we can write the final answer. Negative infinity to negative 2/3 union negative 1/2 to positive infinity. There you go. So it's a lot faster. Example 8. You can factor x plus 3 squared is greater than 0. So we only have a point at negative 3. Okay, for the graph, well, it's a y in the front, so a equals 1 greater than 0, which means it opens up. So we need to actually get through this point, but also open up, which means our graph is just going to touch the graph at negative 3 and come back up. Greater than 0, so the left side is greater than 0, right side is greater than 0. We just can't include the negative 3. There's negative infinity to negative 3 union negative 3 to infinity. Just parentheses on negative 3. So that's the faster way to do that question. Let's look at 2 more. 4x squared minus 12x plus 9 is less than or equal to 0. We can actually factor that one. 2x minus 3 and 2x minus 3 less than or equal to 0. So we have 1 point at 3/2, a solid dot. 4 in the front is greater than 0, so it opens up. So it's going to open up, but touching that point, there you go. And it's less than or equal to 0, so we're looking for anything that is below or on the line. There's nothing below, so the only thing that we can keep for the final answer is this point. It's because it's less than or equal to, so we're looking for anything below or on the line. Equal indicate on the x-axis. So our final answer is just going to be 3/2. So that's a special case for that one. Okay, example 10. This one you can't factor, so let's check the discriminant. B squared is a 1 squared minus 4 times 2 times 9. So it's 1 minus 72, which is a negative 71. That means we don't have any zeros. Well, let's see how that works. If you are not going to have any zeros, that means our graph is not crossing this x-axis at any point. So a is a 2, which is greater than 0. That means our graph needs to open up. So think about it. If you open up and the x-axis, let's say, is above, well, you're going to go through it. Then you're going to have some zeros. So the only way to have our graph open up, but not having any part on this x-axis, is our graph being completely above. So there you go. And the question is looking for less than 0. So we're looking for anything that is below the x-axis. And you can see there's no part, no solution. There you go. That's example 10. And that is everything for 4.15. Thank you.